Hey guys, and welcome back. Today we're going to be talking sampling distributions. We're going to talk about what they are, how you get one, and what kind of things happen when you're using one. So go ahead and stick with me all the way to the end, and you'll learn everything you need to know about what a sampling distribution is. Hey guys, and welcome back. My name is MrCaproni, and this is Probability and Statistics. Today, like I said, we're going to be talking about sampling distributions. Now, if you don't know what that is, it's essentially a probability distribution that's created by grabbing some sample statistic from a larger population. Now, how would you do that? Well, you actually draw samples from the population over and over again, sometimes with overlapping pieces, other times not. But in the end, you take a sample statistic from each one of those samples and then create a distribution out of those. Now, that is a little confusing. So today we're actually going to walk through all the parts of sampling distribution by looking at an example of finding a sample distribution using the mean. Now, if you've watched any of my other videos, you would know that this right here is a group of Larrys, and these Larrys have actually had a fine education at the Larry School of Business, and each one of them received a GPA from that school anywhere from 0 to a 4.0. Now, we're going to look at this GPA as our distribution, and these Larrys that you see right here represent our entire population. Now, in order for us to have a discussion later on about what a sampling distribution is, let's go ahead and look at some of the summary statistics that go along with this population. Starting off, let's go ahead and look at the minimum, the median, and the maximum. Now, the minimum in this case was a 1.2, and that means that Larry literally did the worst out of the entire population. So a 1.2 was the lowest out of all Larrys on a 4.0 scale. It's okay, little Larry. I'm sure you have other strengths. Then you can see here that the median was a 2.6 and the maximum was actually a 3.9. So no one received that 4.0 perfect score for their GPA. Now, this does represent the whole population that we are discussing for this example. And if you look at the whole population as a whole, we can also go ahead and add them all up, divide by how many Larrys we have to get our mean, and then use that to find our standard deviation. And in this case, the mean turns out being 2.5 and standard deviation turns out being 0.8, meaning that on average, the GPAs kind of fluctuate up and down by about 0.8 of a GPA. So now that we have some of those basics, let's go ahead and dive a bit into what an actual sampling distribution would look like coming from this population. Remember, at the beginning of this video, I said that a sampling distribution was when we take a bunch of samples from the larger population and then record some summary statistic from each one of those samples. Now, in this example, the summary statistic we're going to use is the mean. So we're going to create a distribution pulling the mean from quite a few samples we're going to draw out. Now, usually when you're drawing out these samples, you want to always choose the same number of Larrys for each sample, or whatever it is you're dealing with in your example. So what I'm going to do is go ahead and grab 5 Larrys at a time from this larger population. Now, every time I go ahead and grab them, I'm going to put them back in before I grab my next sample, which means there is a chance that some of the Larrys will end up in multiple samples, but that's okay. The whole point of this is that we're going to be drawing a sample over and over again from the same population, and then I'm going to record the mean each time. So let's go ahead and get started with this. I'm going to go ahead and pull my first sample. Now, I randomly selected 5 Larrys from the larger group. Now, once I selected those 5 Larrys, I went ahead and added their GPAs together, divided by 5 to go ahead and get that 2.3. Now, again, 5 is the sample size I chose, and we're usually going to represent that number with N. So N is going to stand for the sample size that I'm pulling each time. So for this sample, I got a mean of 2.3. So if I return those Larrys back to the group and draw a new group, you can see here that this new group had a mean of 2.6. And I can continue this method of pulling out a third group for 2.8, a fourth group for 2.7, and then a fifth group for 2.0. So once you've recorded those numbers, that's essentially it. That is your sampling distribution. So that list of numbers right there above me, the 2.3, 2.6, 2.8, 2.7, and the 2.0, That is my new list of data. Those are the recorded means for my sampling distribution. So we've now created a new list of data coming from the original data, but with a little bit different properties. Now that we have this list of new means, we can actually talk a little bit about what happens with them. First and foremost, if I actually went through the work, I could find the mean and standard deviation of this new list of numbers. And in fact, I went ahead and did that, and you can see that the new mean is 2.48 and the new standard deviation is 0.33. Now notice, the mean is still very similar to the original one. We went from 2.5 to 2.48. They're almost essentially the same. But we can't say that about the standard deviation because the standard deviation dropped from zero 0.8 to a 0.33. Why would that happen? Well, this actually makes complete sense because think about it. Before we had some extreme values in our data, like the 1.7 or the 3.9, but when those extreme values get averaged into a group of 5, you no longer see such an extreme case. So all of these numbers that were really far away from the mean end up kind of getting drawn a bit closer when they're averaged into a mean of a sample. So we end up lowering our standard deviation every time because really what we're doing is taking all of our points and moving them closer to the center. Our sampling distribution just is not going to have the spread that our original data did. Sampling distributions alone are actually not very useful, but when we start discussing them with a normal curve, now all of a sudden we start getting a whole bunch of applications on how to use a sampling distribution to help us with a whole bunch more complex probability questions. Now, why are we able to do this? Well, we're actually going to cover a lot of that in my next video because it involves understanding this central limit theorem for our sampling distributions. And we're going to go over all of the stuff about the central limit theorem in my next video. But for right now, just know that if you did have a normal sample, like a normal distribution like the one on the screen right now, then just realize that what we talked about, the mean staying the same, but the standard deviation getting smaller, would create another normal distribution. The curve would just be slightly different. And we're going to end up being able to use that curve for a lot of really cool applications. So a sampling distribution itself may not be super helpful, but once we start applying it to other situations and using other theorems to go with it, it becomes a very powerful tool in our belt. So it's definitely something you want to know as much as possible about. Feel like you've learned a bit about sampling distributions? Good. Go ahead and hit that like button below to let me know. Now, what actually have we covered throughout this video? Well, we talked about what a sampling distribution was. The fact that really it's just drawing samples from a population over and over again, and then recording some summary statistic about that sample. And that new list of summary statistics is going to be our sampling distribution. Now, in our example, we did it with the mean, but you can actually use other things like the standard deviation or maybe the slope or something when you're dealing with this type of work. But in our case, we did stick with a pretty basic form by looking at the mean. Then we went ahead and broke down where this is going to lead next. We're going to end up using the central limit theorem in my next video. And when we're using that, we're going to see how we can apply this sampling distribution idea to start tackling some pretty difficult probability questions about populations as a whole. So I hope you join me with that one, and I hope you learned something new from this video. Remember, my name is MrCaproni, and this has been Probability and Statistics.